This is Calc 1, section 1.2. Let me show you the problems first. For those of you that don't have the book and aren't getting it, page 33. So we have just 1 to 9, all 11, 13, 15, 17. So here's that. 3, 4, 5, and 7. So on the next page. 13, 15, 17. Okay. 1 and 2 is just recognizing what kind of functions you have. So just state what type of function you have. Okay. And please notice the difference between 2a and 2b. This is pi to the x, this is x to the pi. Okay, this is considered exponential. So 2a is exponential, b is a power function. Okay, so if you have a variable to a constant, I think of like x cubed. It's a power function. Pi to the x is exponential. Okay, that looks like a polynomial. That looks like trig. This is a rational expression. Okay, rational functions, it's a polynomial divided by polynomial. This is just a big mixture, so let's just call that algebraic. Okay, number 4, which is which? Okay, 3x is a line, straight line, so that's capital G. 3 to the x power, that's exponential, so that's little f. Cubic function, so that's the red one. That's capital F. B should be little f. And then the cube root swings over like that, so that's little g. We have some questions involving domain. Okay, find a domain of something like that. I'll do number 6, 1 over 1 minus tangent x. Well, that 1 over 1 minus tangent x cannot equal 0. So first I solve tan x equals 1, which is the same as sine x over cosine x. That happens at pi over 4, 5 pi over 4, and multiples of pi after that. Okay, so x is equal to pi over 4 plus k pi, a multiple of pi, where k is an integer, and that gets thrown out of my domain. So the domain is all real numbers minus the set consisting of pi over 4 plus k pi, where k is an integer. Okay. Number 8 says f of x equals 1 plus m times x plus 3. Well, all of these lines go through the point negative 3 comma 1. So negative 3 comma 1 is a point in common. And then you just spin around to get a different slope. Okay, the point slope form is y minus y1 equals m times x minus x1. You can rewrite this as y equals, or y minus 1, sorry, equals m times x plus 3, which is like x minus a negative 3. So all of these lines go through negative 3, 1. And then you just change the slope. So here are several different lines that satisfy that. Okay, number 11 says f of 1 is 6, f of negative 1 equals f of 0 equals f of 2 equals 0. Okay, so if it's going to be a polynomial where these are zeros, that automatically gives me x plus 1, x, and x minus 2, right? So all of these give me 0. If I plug in negative 1, I get 0. If I plug in 0, I get 0. If I plug in 2, I get 0. But now there's a k in front. Why the k? Because I have to account for the fact that f of 1 is 6. So now I plug in 1 and plug in y is 6. I put a 1 here, 1 here, 1 here. 6 is the answer that you get. That's like y. So 6 equals k times 1 plus 1 times 1 times 1 minus 2. So that gives me k times 2 times 1 times negative 1. 6 is equal to negative 2k. K is negative 3. So plug in negative 3 back here. Function f of x is negative 3x times x plus 1 x minus 2. Okay, 15. F is 9/5 c plus 32. Okay, that's like y equals mx plus b. I plug in 0, I get 32. I plug in 5, y5, just convenience. I get 9 plus 32, which is 41. So it looks like so. Okay, so when c is 0 degrees, f is 32 degrees. Okay, slope is 9/5, which means when c goes up by 5, f goes up by 9, or roughly double. 17 says something about the chirping of birds. So you take a couple of ordered pairs, essentially. You have 117 chirps per minute at 70 degrees, 173 chirps per minute at 80 degrees. Those are ordered pairs. So x, y is n comma t. T is a function of n. I have 113, 70, 113 chirps at 70, 173 chirps at 80. So you find the slope. 80 minus 70 over 173 minus 113. That's 10 over 60, or 1/6. And then use y minus y1 equals m times x minus x1. I'll let you finish the rest of that. You have the m. What do I use for x1, y1? You could pick either this one or this one. I guess this one's a little bit easier. Okay, and in case you didn't see it, at the same time as when I wrote it here, I got it at my notes. For number 2, fold this in half a little bit. Here's number 2. So answers are exponential, power, polynomial, 5th degree, trig, rational, and algebraic. And then for number 4, we had capital G, little f, capital F, and little g. That's the solution for that one. All right, so that was section 1.2.